Hi, in this video we're going to talk about meta-analysis. When scientists want to get a real picture of whether a drug works or not, or if there is a link between two variables, they need to examine all sources of data as critically and objectively as possible, using meta-analysis. It is a statistical method that quantitatively combines the results from different studies about one research question. So, basically, it can provide an overall estimate of the net benefit or harm at intervention, even when these effects may not be apparent in the individual studies. To achieve it, the study must provide a clear description of difference among studies and explaining the reasons why studies may have reached varied conclusions. This is typically referred to as heterogeneity, which may be explained by random chance alone or may be due to basic difference in trial design or participant across studies. But essentially, why conduct a meta-analysis? In contrast, with narrative review, meta-analysis introduces two fundamental changes. It works directly with the effect size of each study rather than the p-value, and includes all the effects in a single statistical synthesis. This is critically important for the goal of computing a summary effect. Overcoming bias. It can only be achieved if carried out on a rigorous systematic review. Precision, which refers to the extent to if the observed results could be reproduced exactly given the same intervention and study design, versus validity, that is the extent to which the study measures what it is intended to measure. Transparency. This means that a good meta-analysis should allow readers to determine from themselves the reasonableness of the decision taking and their likely impact on the final estimate of effect size.
To conduct a meta-analysis, scientists must compute an effect size. This is, in a general way, a value which reflects the strength of the relationship between two variables. Also, the variance for each study. Then they will work with these effect sizes to compute a weighted mean. This refers to assign more weight to the more precise studies. So to get there, scientists must to develop a protocol, formulate the research questions, searching for the evidence, and assess the quality of the studies. To do this, they recollect information from databases, like the one shown here. But some studies may never get to see the light. For example, negative studies may be less likely to be published. This is known as publication bias. That's why the research community recommends to look for information obtained from other sources. This is called the gray literature. Still, there are always some limitations. For example, when heterogeneity is too large, meta-analysis generally does not yield meaningful results, and as mentioned before, publication bias. However, meta-analysis is considered the cornerstone of evidence-based medicine. Thank you for watching.